Alrighty, today we're going to be looking at AR. Now that's not handheld AR with your mobile phone, but rather live production, virtual production AR. Could be used for set extensions potentially as well. And just that kind of general real-time VFX stuff. You know, putting a digital character in a real world, for example. So I'm in Unreal here. I've got a basic project, what I'm going to call my virtual production starter project, if you will, at this point. So I have enabled the alpha through tone mapper option. You may remember that one from the green screen tutorial. I've also in the plugins enabled the Blackmagic plugin because I'm using a Blackmagic card. Of course, enable the Azure or Bluefish or whatever you happen to be using if it's different. I've enabled the media utilities and framework, these two, framework utilities and IO framework. I've enabled Live Link, and I'm using the Panasonic UE150 behind me today, so that uses 3D. So I've also enabled 3D, but whether you're doing, say, a Vive Mars system or a Moses or something else, enable the appropriate Live Link for your device. I'm also going to need the camera calibration plugin. This allows me to use lens files. Go ahead and restart Unreal, and then you'll be greeted with this screen where we can begin. So I'm going to start by just importing my lens file, just so I can apply it to my camera. I have on my desktop here, this one. Perfect. I'm also going to go ahead and create my media IO. The order of things I don't think makes a huge difference here. Make a folder called media. I'm going to call this MP Ultra Studio 4K. Figure my proxies, so 1.1, because I just have one coming in. We're going to composite in the engine, and then I'm going to send it out again. Yeah. Alrighty. So my media source, I'm going to choose Blackmagic, Ultra Studio, and do 10 progressive, 2997, apply. Output, I'm going to do the exact same thing. 1080 progressive, 2997. I do have a Genlock signal. I've noticed the Panasonic, at least, the tracking data likes to drift away from the video in and out when it isn't Genlock. So I've got a Azure Gen 10, just creating a Genlock signal for all my devices here. So I'm going to select external so it stays Genlocked with all the other devices. Also going to enable engine Genlock down here, which is just going to limit our frame rate so we're not rendering more virtual frames than our real frames. Apply. Apply and save. And you'll notice I should now be at 30 FPS. If you don't see this bar at the top and you'd like to, then it's under editor preferences. And then I just search memory and scroll to the very bottom, and it's this very bottom one, show frame rate and memory. And that just gives me this handy little bar up here. All right. Now I also need to set up my live link. So I'm going to go to virtual production live link. I'm going to add a 3D source. I'm just going to do all zeros, which just means any incoming connection. Which in my case is perfect because then I've got my camera here and then we're good to go. Alrighty, I'm going to create a new level and I want it to be completely empty like this. And so what happens here is everything that is straight black like this that goes on in the void is actually alpha in Unreal when we enable the alpha through tone mapper setting. So this is all transparent according to Unreal, which is why we can't have things like clouds or skybox or any of those objects in the scene that would interfere with that. So now that we're in here, I'm going to add a target point and I'm going to set it for my camera. I'm going to zero it out. I'm going to add a cine camera like so. Parent it to my target point. Reset it. And then I'm going to add the live link and lens to it. So live link, subject 1, and lens, like so. I'm going to choose my lens file, and I'm going to set to the film back to use the lens file as well as apply distortion on it, like so. Now, my target point I need to set to the height of my camera. So just grab a tape measure and look. Literally, if you were to straighten the camera out, which I could do, like so, just measure from the center of the lens to the floor. This is for a PTZ because the PTZ doesn't understand its location. If you use a tracker that tracks location, like a Vive or a Moses Star Tracker or a Red Spy, then you wouldn't need to do this step. You could skip it. Now, I've already measured this one. I know it's 140 centimeters off the floor, but we have our camera set up. I'm going to just start with a basic cube in my scene and just put it in front of my camera so we can test everything is working. Just make sure the camera can see the cube. Yeah. So we need to light our scene. Now, I could meticulously go in and add some lights, but what I prefer to actually do is use a skylight, like so. Switch it to specific cube map, and then what I could do is I could use like a 360 camera or something to create a HDRI of the room I'm in at the location where my AR is going to be placed. That would be the most accurate. I'm just going to grab a random one here and add it. I still can't see the cube. It is nowhere to be found, apparently. But explain it. It is all the cube. Let's shrink that a touch. All right. So I need to do my lens limits next. So if you don't remember them from the green screen tutorial, essentially the camera encodes its lens in just a random arbitrary value, whichever, if you have wheels on the camera, it's how many times the wheel time. That doesn't mean much. So Unreal takes the smallest value of that it's ever seen and the largest it's ever seen and normalizes it to a 0 to 1 range, which our lens file then says at 0 it's this many millimeters and at 1 it's this many millimeters. So that's the process there. And I can actually check it because if I look in focal length here, you can see they're actually identical. So whenever I add a live link subject, restart Unreal, that kind of thing, these usually get reset to nada. So I'm going to zoom out and you can see, I'm just going to spam the zoom out. Yep, perfect. Zoom in and you'll see that starts to climb as well. I can spam zoom in just to make sure I got it. And now if I go out a bit, it's correctly done the lens, and now my cube isn't massive. Perfect. So I'm going to tweak, I'm just going to turn off auto exposure in the camera. Lens, exposure, set that to manual, and 12 should do us. Perfect. Now let's do the compositing step. So I'm going to create a new folder called materials, and I'm going to create m_post_process composite, like so. Go ahead and open it. Now in here, I'm going to switch it from surface to post-process, like so, which will give me just the emissive color output. I also need to double check, it should be by default, but I want this to happen after tone mapping so that we don't affect the colors of our video coming into Unreal. Last thing we want to do is crush all the colors. And just search post-process here, and there we go. Scene color after tone mapping, that's perfect. Now if I grab my scene color, no, scene texture, perfect. I'm going to switch this to post-process 0, and if I put that into the emissive, you'll see it's the same. That's fine. Now on my cinema camera, I'm going to put this on the camera. So rendering features, post-process materials. You'll see we already have one in there. That is the camera distortion that we added earlier. It's fine. Make sure that one's selected, and I'm going to drop it in there. And this should go before the distortion. The distortion doesn't affect the incoming video. I think this is after. I think it starts at the bottom of the list and goes up. That's why it doesn't affect it. Regardless, we can now see our handiwork. So if I grab a component mask, there we go. I can then mask out the A and leave the rest. So this is our alpha channel. I can plug it in here and save, and you can see we are getting an alpha. So Unreal's is inverted for some reason, so it's a alpha of 1 where there isn't an object and an alpha of 0 where it is, but still an alpha channel, so that's more than fine. Now, what I also need to do is grab our video footage. And so that is something that I have not done, is I need to drag the media bundle out just so it is playing. So bundles, drag it out, and that's correct. Perfect. I'm just gonna shush that to the side. No one will see it. I just care about the texture here. So in my material, I'm just gonna drop the texture in here like so. Now I could do a very basic lerp between the two, like that. Plug that into there, plug that into the output, and use the alpha. Oh, it's a full float, so that. Use the alpha to combine them, and that does work. Ta-da, we have a cube in our real world. However, this has a problem with it, and I'm going to show you what that problem is with bloom. I can bump this up to some ridiculous value, and there is no bloom. That's because it's something to do with pre-multiplied versus post-multiplied alpha. I'm not the best person to explain what that is, I'm afraid. But Unreal is one of them, and we need it to be the other. So there is this concept, I guess, called an over operation. So I'm putting one over the top of another, which is a bit different to the simply one or the other, which is what a lerp is. We actually want to put it over the top of it. If you use, I'm pretty sure it's a Photoshop layer and After Effects. If you use any of those tools, you'll know what an over is. But it's rather simple. What I'm going to do is I'm going to delete the lerp. I'm going to multiply the alpha by my video footage here. And so we can see what that looks like if I just plug that in here. We just get the cube black with the video footage. And then I'm going to add back the cube, I guess, into my emissive. And you can see very bright, but it works. Would probably make more sense if it was an emissive object instead of a non-emissive object. Which I could probably demonstrate a bit better if I just create a quick emissive material. Like so. Let's go unlit, whoops, unlit. Maybe say maybe 50. Plug it into the emissive channel. Should have a more natural glow to it. Well, it's got a lot of glow. Oops. Perfect. It's working, is the main thing. Now, AR in this capacity will always be on top because the alpha, where there isn't an object, will always be behind. That's just the way the cookie crumbles. So, how can we put an object in front instead of behind? So it's not too difficult a problem to do. We're going to use a mask. Now we're going to use a holdout mask. If you've ever done any 3D rendering, especially with compositing, you may already know about a holdout mask. So what I'm going to do is I'm going to create a new material and I'm going to call it m_holdout. And I'm going to use a material mode that you may not know about in Unreal called alpha holdout. So under opaque, I'm going to change it to alpha holdout. Now we get a warning, it has to be unlit, and it's gone. So we do, and this is very important, we do need to change in the translucency settings, I don't know why it's there, this translucency pass needs to be set to before DOF. If you don't see a black sphere, then check this setting. But now that I have a black sphere, that's my alpha holdout. That is essentially going to punch a hole through any object is in front and render it as a 0 opacity. So I can just simply grab another cube, like so, put it sort of in front of this one, and then apply my Holdout Mask to it. And you'll see I perfectly cut it off. Now the bloom does get composited a little bit. That's all right. Can also do a varied amount of holdout if I wanted to. So I can say grab here and do 0.5 and plug that into the opacity instead. And I should get a slightly, it may not work on an emissive mesh as well. Might be as obvious if I grab the default shape material. There you go. You can see now I have forced this object to be translucent in one section without actually using a translucent shader on it. However, this method does work with translucent shaders. So if I was to duplicate the cube again, and let's just make a quick translucent, like so. Whoops, change that to translucent and say 0.25. Plug it into opacity. Save. And put it there. You can see it's a little hard to see, but it is also translucent. So we can do all sorts of interesting effects here with that. Now, you may run into a problem, and I'm going to demonstrate it on my translucent mesh by, let's just set that to black so it's more obvious. And then I'm going to plug a gradient into my translucency. Linear gradient into translucent, and I should get, aha. So in my material preview, you can see I have a perfect translucent gradient. However, in the real world, I actually have this ugly looking banding happening. And so the reason for this is Unreal's buffer format. So I can actually see the settings there, and you may have experienced this. I did mention it in the comments of my green screen video. If you wanted the garbage mask to fade as opposed to being a 1 or a 0, someone else ran into this issue with it. But essentially, if I type buffer, and this is different to the G buffer in Unreal, which I know annoying, but I have this here. Frame buffer pixel format, and you can see by default it's 10-bit RGB, 2-bit alpha. That means I only have 2 bits in the alpha channel, which is why I get this stepping. Now I have 2 other options. I have float RGBA. This will mean that it's 32 bits in every channel, including the alpha. The downside of that is it's going to make your Unreal UI look very funky. Put a picture up. The alternative is 8-bit RGB, which is just 8-bit in every channel. This is what I'm going to use. It's fine. YouTube only uses 8-bit, so it's not like I'm missing out on any extra information that you could have seen. And for most people's cases, it'll be fine. So I'm going to save my map, AR map. Whoops. All right. For some reason, when you first open the project, you may notice that your post-processed material breaks. I have no idea why this is. It's happened in basically every version of Unreal. Essentially, this texture sample is for a brief second set to color instead of linear color, and then set back again, which you can see when I did set it to color breaks the material like what we're seeing. I think it's something to do with the media texture before it's created properly is set to color, like a different color method or something. That's my best guess. However, simply opening the material and then applying it or saving it, and then you can close it and it's working just fine. And you'll also notice that I now have a nice smooth gradient. I have a nice smooth gradient on my cube. And not a funky Unreal UI. Alright, and just like that, we could do anything we really wanted to in front of some video feed. Do some really interesting effects, 3D characters, real-time previs. I know not this exact process, but for the TED TV show, Seth MacFarlane's production company invented a tool that they could use to previs Ted, the bear, in the shot while they were filming. And this is a very similar technique. Could have, if you have a virtual character, could do a puppet, hook some Xbox controllers up in Control Rig to control various motions, and you could create a digital puppet and film it live. It's really a lot of opportunities here, and I'm sort of would love to hear what you guys are doing with it. Now, I'm going to look at a bit more in another video, a bit more advanced setup with this, with a character, with some fake shadows and all that kind of stuff. So keep an eye out for that one. Otherwise, thank you for watching, and enjoy the rest of your day.